Now let's take another subtopic, limits and continuity of functions of several variables. Alright, now recall that in function of one variable, if x approaches a number c as f of x approaches a number L, the L is called the limits of the function f of x. Now, mathematically, we write that lim f of x as x approaches c equal L. So it is assumed that you have studied calculus of one variable and you know what we talk about limits of a function. So here I'm taking limits and later we'll talk about continuity. So I assume you know limits. Now this is the mathematical definition of limit of a function. We can also define limits of function of one variable using epsilon delta definition. Now, epsilon delta definition. I'm trying to link it. Let epsilon greater than 0 be given. If there exists delta greater than 0, however small, because we must do that, however small, such that the absolute value of f of x minus L is less than epsilon whenever 0 is less than x minus c and less than delta. Then the limit of f of x is L. Now this is epsilon delta definition of limit. You see, I'd like you to get our package on calculus of one variable, where you also look at how we evaluate limit by epsilon delta definition. But another thing is that most students find it difficult to know what epsilon or what delta. So if you look at that package, we really use example using tabular approach to show you what we really mean by epsilon and delta, how we can find them. So we say let epsilon greater than 0, that is positive. So let epsilon greater than 0 be given. If there exists delta greater than 0, however small, such that the absolute value of f of x minus L is less than epsilon whenever 0 less than absolute value of x minus c less than delta, then the limit of f of x is L. That is for one variable. Now we can extend this. To functions of several variables. So limit of functions function of two variables. Let me look at two variables, variable x and y. I'm taking two variables now, x and y. Okay. If x approaches a number a and y approaches a number b, as f of xy approaches a number L. The L is called the limit of the function f of xy. So mathematically, we write that limit f of xy as x approaches a, y approaches b equal L. Okay, so this is how we write for functions of two variables. You know, this one was function of one variable. So for function of two variables, we write in this way. Now, we can also use epsilon delta definition for functions of two variables. Epsilon delta definition. Now, let's f of xy, a function of two variables. If given epsilon greater than 0, then exists delta greater than 0, such that the absolute value of f of xy minus L is less than epsilon. Whenever 0 is less than x minus a squared plus y minus b is less than delta, then the limit of f of xy is L. So if we can find, if given epsilon greater than 0, we can find delta greater than 0, such that if absolute value of f of xy minus L is less than epsilon, we also have that x minus a squared plus the absolute value of y minus b is less than delta. So the limit of this function will be L, or we say the limit exists. Okay, so In this context, we are going to evaluate limits of function of two variables using epsilon delta definition, and then we also use the normal substitution that we know. Let's take some examples. Now, before we take the example, let's take theory. This is some theorems that will help us to evaluate the example. So, let g of xy and h of xy be two functions. If you see these are two functions and they are single valued, so let me put that. Two functions that's single value. If x approaches A and y approaches B, so that limit g of xy as x approaches A, y approaches B is equal A, and the limits of h of xy, x approaches A, y approaches B is equal B. Then limit x approaches A, y approaches B of f of x squared plus, or let's say plus or minus, h of xy will be equal A plus or minus B. That is one. Usually what I'm doing here, I can use this to multiply this. What I mean, if this one, the limit is A, another limit is B, then if I take the limit of f of xy and the limit, sorry, we were using g, okay, limit of g of xy and the limit of h of xy plus or minus, it will also give us this. Then for I, limit x approaches A, y approaches B, g of xy, yes, times, let me use line this time, or dot is the same, times mean h of xy, x approaches A, y approaches B, will be the same as A times B. The same is also true for I, that lim g of xy, x approaches A, y approaches B, divided by, let me use this sign. If you divide it by the limit of h of xy as x approaches A, y approaches B, it will be equal to A divided by B. Now, if there exists a scalar also, so that we have the scalar times this and the scalar times this limit, it will be the same as the scalar times this particular limit. also divided by the scalar. Sorry, we are talking about multiplication. It will be the same. For addition, it will also be the same. If you add scalar here, then it will be the same with the limit of this plus the scalar and the limit of this. So these are theorems that can help us. And as we are going to evaluate some examples, we'll also see it. Let's take the example now so that we can apply this theorem. Now, we look at this example. Evaluate lim x squared plus 1 over x squared plus y squared as x approaches 0, y approaches 2. Using epsilon delta dimension, prove that limit of 2x squared plus 3y minus 1 is equal 4 as x approaches 2 and y approaches 1. Now let's pick the solution for I. We have lim xy plus 1 over x squared plus y squared, x approaches 0, y approaches 2. Now, this is how we evaluate the limit of functions of several variables. So, in this case, which is 2 variables, we are first of all going to evaluate the limit of one variable while we keep the other constants before we now evaluate the other one. And that would be the same as writing lim x approaches 0, y approaches 0. Then what I will do is to first of all put for x. So I will remove this and pick it this way, that x approaches 0. That is the one I will first put for x, y plus 1 over x squared plus y squared. Of course, you see this one is out. Now this one will give me 0 times y. I will put it in the place of x plus 1 over 0 squared plus y squared. So what I have here now become lim y approaches 2. Sorry, this y approaches 2. So y approaches 2 of 1 all over y squared. So I'm going to take this limit now, which is 1 over 2 squared. And that gives me 1 over 4. Now understand the concepts that I first of all put for x. I pick 1, while 1 is held constant. Then when I do that, it will give me this. Then this one remains 1 over y squared. Can then also allow y to approach 2. So I put 1 over 2, which gives me 1 over 4. So that is how we evaluate it. If it were to be 3 variables, then I will put one after the other so that I can now get the limits. Now number 2, that is I, says that we should prove using epsilon beta definition that the limit of this function is 4. Now, let epsilon greater than 0 be given. It exists delta also greater than 0, however small, such that the absolute value of 2x squared plus 3y minus 1 minus 4 is less than epsilon whenever we have 0 greater than x, okay, x minus a, you know, a in this context is 2, x minus 2 less than, okay, square, Then we have less than delta, and then y minus, okay, y will be plus 1. You know how? Because we have minus 1. So minus times minus make it plus here. Less than delta squared. So that, I can then write this as absolute value of 2x squared plus 3y minus 5 is less than epsilon whenever 0 is less than x minus 2, x minus 2 less than delta. I can write it in this one, and then 0 is less than y plus 1 less than delta. So I just divide through by the square, so I reduce it to here. Which also, you see, now what happened here is that I want to see how I can find delta. Epsilon is given, so let me find delta to see how I can find it. Now, let me pick this first one. If I pick that, I will have 0 is less than x minus 2 and less than delta. And then by absolute value, inequality involving absolute value, you know how to open absolute value. That here I will have minus delta is less than x minus 2 and less than delta. And for me to remove this 2, I have to add to both sides. So 2 minus delta is less than x and less than delta. Okay, less than delta plus 2. I'm adding 2 to both sides. If you add the 2 here, then this will go. You have this. Okay, now let me call this expression star. Also, if I pick the other one, which I put 0 less than y plus 1, the absolute value of y plus 1 less than delta, I can also write it in the form minus delta less than y plus 1 and less than delta. Then what will happen is that I have to subtract. So I have minus 1 minus delta is less than y and less than delta minus 1. You see, by subtracting 1 on both sides, you can have this. I'll call this one another expression, double static. Now, from expression double static, the static, which talks about x, and we have seen in this question that x is squared, while y is not squared. So I'm going to square x. Squaring static, I will have 2 minus delta is less than x squared and less than delta plus 2 squared. And then we have another one, which is minus 1 minus delta is less than y and less than delta minus 1. And that one is not squared. Okay. Now, we observe another thing, that in x, 2 is multiplied, and then 3 is multiplied by y. So, I'm going to multiply 2 minus delta squared less than x squared and less than delta plus 2 squared by 2, and minus 1 minus delta less than y and less than delta minus 1 by 3. So if I do that, this place become 2 minus delta square is less than x squared and less than delta plus 2 squared, and then that will give me 2 4, by linear expansion, 4 minus 4 delta plus delta squared is less than x squared and less than delta squared plus 4 delta plus 4. Yes, that is what this expansion will give me. And don't forget, these two will multiply. We are multiplying 2, okay? So I have something like this here, 2. Then this will now give me 8 minus 8 delta plus 2 delta squared is less than, there is 2 here, less than 2x squared and less than 2 delta squared plus 8 delta plus 8. Now, let me call this expression 1. Then, we also have from here that we kept, something was here, supposed to multiply by 3. We're dealing with one after the other first. So, going by this, by 3, you see, if we multiply this by 3, we then have minus 3 delta is less than 3y and less than 3 delta minus 3. This expression is 2. Now, if I add 1 and 2, adding 1 and 2, this 1 and 2. If I add this 1 and 2, if you add this and this, you have 5. Then you also have minus 11 delta, that's minus 8 delta, minus 3 delta, minus 11 delta, plus 2 delta squared is less than 2x squared plus 3y. Now that, if you add this and this, plus, okay, less than 2 delta squared, like this. Then if you add this to this, you have plus 11 delta, then you add this, you have plus 5. Okay. That means, you see, this is 5. So, if I bring any one to this side, I will have minus 11 delta plus 2 delta squared is less than 2x squared plus 3y minus 5 is less than 2 delta squared plus 11 delta. Now what we need is delta. And so I will allow this and this to cancel themselves, because here, if you don't take this to this side, they become 0. This one. So this one will not. This 11 delta and the minus 11. So I can write minus 11 delta is less than 2x squared plus 3y minus 5 is less than 11 delta. Now see, I am able to come back to the given equation, to the given functions where we define, I think we define somewhere. So I'm able to get it back. And so now, if I compare this particular one to here, we can then see that 11 delta is equal epsilon, which means delta is equal epsilon over 11. So I can able to find delta. This is the same with epsilon. So now, or you can write it that the delta minimum, delta minimum will be equal to 1 and then 11, epsilon all over 11. So I'm able to show that truly 4 is the limit of this function. So this is how we evaluate functions of several variables, like 2 variables that we are doing using epsilon delta definition. It's very simple to follow. If you are given a function, critical look of the function, provided you know that if given epsilon, if you can find delta, then the limit exists. So it's very simple to follow. Now, I want to look at continuity of function of several variables. Let's f of xy, the function of 2 variables, x and y. F of xy is said to be continuous at the points x is equal a, y is equal b, if the following conditions are satisfied. 1. Limit of f of xy as x approaches a, y approaches b must exist. Number 2. Lim f of xy as x approaches a, y approaches b must be equal to f of ab, and the limit of this function must be equal to when you substitute the value of a and b must be the same. Now, number 3. Lim x approaches a, y approaches b of ab must exist. So these are the 3 conditions. These are the 3 conditions that will make us to say that the function is continuous. Alright, let's pick example so that we can really understand. Now, we look at this example, show that f of xy is equal x squared minus 3y is continuous at the point 1 and 2. So we look at the solution. We have that f of xy is equal to x squared minus 3y. Now, number 1, we have to find the limit of x squared minus 3y as a function as x approaches 1. So this is for 1, and then y also approaches 2, which we have already known from our evaluation of limits, that we can write this like y approaches 2, then y approaches 2, then we also have lim x approaches 1 of x squared minus 3y. So this will give us lim y approaches 2, and then we have this function. If we put here, we'll have 1 minus 3y. So we then evaluate this at this point to have If you evaluate that limit, we have 1 minus 2 minus 3, sorry, minus 3 times 2, that is 2, x approaches 2. That will give us 1 minus 6, which is minus 5. So the limit exists, minus 5. That is condition 1, which is this, limit exists. Okay, now what about condition 2? We said that limit f of x y as x approaches a, y approaches b must be the same as f of ab. Okay, so f of ab is 1, 2. That will give us now x squared minus 3, and this will be what? 1 minus 6, which is minus 5. So you can see we have minus 5, and the limit is minus 5. Now, another one, which is number 3, the limit must exist at that point. Yes, of course, condition 3 is very simple to find out. It's very simple to find out. If I put these points, like I'm putting here, you see the limit exists. There are some functions that if you put, it may not exist. For instance, if the functions with maybe f x y is equal square root of 1, yes, square root of 1 minus 3y, square root of x squared, sorry, minus 3y. We know that this function wouldn't have to exist, because when we evaluate this, we have 1 minus 6, and then we have square root of minus 5, which we say is not defined at this point. But you know, by complex number we can do this. I'm not saying that we cannot evaluate something like this, but the original definition of limit will be evaluated here. Or if this function were to be maybe x squared minus 3y over x. Look at this function. If x approaches 0, y approaches maybe 1, this function will not work at this point, because it will give us undetermined. Yes, it will give us undefined. It will not be defined here. So that is what is talking about. It must be defined at that point. It must exist. So you can see that even this function we are trying to work on exists at this point. So condition 3 is satisfied. Condition 3 is satisfied. Hence, function f of xy is a continuous function. So that is what we take all about limits. So I want you to get some exercises, also practices on your own, so that you know how to evaluate the limits of functions. I've given you all the tips that will help you do that. Thank you.